So, hello to my talk. I'm going to talk about vulnerability management, and I have to admit the coolest thing about my presentation is the title of the slide deck, and the saddest part is the title wasn't even my idea. And the problem is a bit vulnerability management is a bit boring. Basically, it's very hard to illustrate how to manage vulnerabilities. I have had an awareness training 2 weeks ago, and I usually put my favorite funny cat videos in my awareness trainings. So unfortunately, I can't include cat videos in this slide deck. But I'll try to show you how we do vulnerability management. We have a vulnerability database, which is public, and we've been doing this for quite some while. And as I think vulnerability management is very important for our industry, because it doesn't matter if you are a pen tester or an administrator or a researcher, vulnerabilities are always important for you to understand risks and to put them in a context. So basically, my name is Marc Ruef. I'm here from Switzerland. I have a website and I wrote a few books. So what I'm going to talk is, or what I'm going to show you is how we approach the vulnerabilities in our database, and I will show how the vulnerabilities are maintained by other vulnerability databases. So what is a vulnerability database? The definition is quite simple. It's a database which collects vulnerabilities. And there might be different reasons why you want to do that. Basically, most people do that for vulnerability management to see what vulnerabilities are available and which patches might be applied to guarantee a minimum level of security. And vulnerability databases might be fun to do some statistical analysis. Perhaps if you want to see how many advisories got released for a specific product before you purchase this product, you might imply how often you have to patch and how much of maintenance you have to approach. So this is just a short overview of our vulnerability database. Most vulnerability databases have a listing of the latest entries, and if you click on an entry, you see the details for the specific entry. This one is Microsoft Internet Explorer, buffer overflow, which got released recently. So when you start to do vulnerability management and to collect vulnerabilities, you have to think about how you want to do that. And the first thing you have to think about is how many vulnerabilities do you want to maintain in your vulnerability database. Ideally, you are going to provide a full coverage. You're going to add every vulnerability that there is, but this takes a lot of time. So most companies or vulnerability database vendors use a selective collection. For example, if you are a company and try to maintain a vulnerability database, you usually do only add products that you have in your inventory. But there might rise the problem, what if you add vulnerabilities for a specific product today and you're going to introduce a new product tomorrow? You would have to add all the old vulnerabilities to see how this product acts in the life cycle of security. Our vulnerability database is covering the most popular products and the most interesting vulnerabilities. So this means if there is a very unpopular web CMS with some obscure cross-site scripting, we are not really interested. But of course, we provide information for Microsoft, Adobe, and the more big players in the business. And if you start to do vulnerability management, you have to think about for whom are you doing this? Is this a public service you want to provide, like we do? We see this as an advertisement for our company, but we also use this information internally for our pen testers. And we try to map a finding in a penetration test to our vulnerability database. There are some commercial vulnerability database players like Secunia, which provide commercial feeds. You have to pay them and you get more or detailed information. And I know of several companies which use an internal database which they use for inventory maintenance and patch management. So this is the information that usually is the minimum for an intelligent entry. An entry usually has an ID, has a title, a small description, ideally a risk rating, and if you are a bit more fancy, you provide additional sources, so you might be able to do some more research. But details are cool. In our database, we have different groupings of information. So we have software information, vulnerability, advisory, exploit, countermeasures, sources, tools, and miscancellors. And I have just displayed a few of the exploit information we are collecting. So, for example, is an exploit available? What was the disclosure date of the exploit? The name of the developer? In which language was the exploit written in? How reliable is the exploit? And stuff like that. And the problem is, as more details you are collecting, as more data you have to mangle, we have, in the last 11 years, compiled more than 13,000 entries, and we use approximately 150 data points per entry. That means we have 150 different information details available in an entry. And because it's impossible to add all of them because you don't have the time and often you don't have the information. So we have to provide a priority, which data, which information, which data point is important for an entry and which must be added and which shall be added. In our priority, we have defined that 33 information facts must be added if they are available. 32 are available. If they are available, you might add them, and you have, if you have a lot of time, you have, or you can add the other 85 information data points. The statistical analysis of all the entries we've made in the last 11 years shows that we usually add about 50 data points per entry. And the worst entries have just 26 data points, and the best entries have 90 data points. And as more popular a vulnerability is, as more interesting, as more time we invest to add more data, to do some further analysis, to try to develop our own exploit, to add additional data, which might be interesting for us internally and for our customers. And just as a trivia, we usually add approximately 15 entries per workday. That's the average we have had during 2014. So where do you get information about vulnerabilities? I think that's nothing really new. You have vulnerability databases, you have contributors like CDI, you have a lot of mailing lists, InfoSec mailing lists like BugTrack and Full Disclosure, or you have advisory vendor mailing lists, which might also include vendor advisories. We are also very much focusing on code repositories because we think that whenever a commit is available and it is security related, of course, it might be in the future pop up in a release note or in an advisory. So the moment we are monitoring the code repositories, it gives us some advantage because we might be much faster than the others if they wait until the public advisory, which sometimes takes a few days or even weeks until it got released. Here are some of the major players of vulnerability databases, and I've tried to compile the pros and cons of them. There was some interesting shifting in the last few years. For example, OSVDB closed the listing on the main page a few years back, and they closed the RSS feed, and they prevent you from downloading the database anymore, which is very sad. And Secunia introduced a few weeks ago the requirement that you have to log in on the website to see their vulnerability listing. And I think that's not a very good progress because it makes the information not really visible anymore. You have to put much more effort to gain this information you're interested in. I've tried to rate these different vulnerability database sources. 3 means that the source is supporting this feature often or fully. Number 2 is just partially supported. 1 is sometimes, and the 0 is that the source isn't supporting this. I'd like to point out that on the bottom is our own vulnerability database, and of course we got the best scoring. That's not a surprise, not because we are much better, but because the attributes that are important for this slide are also important for me, and that's the reason why we have implemented all these features. Of course, if somebody else is going to do an evaluation of the different sources, we might not come out on top. The list is sorted alphabetically by the name of the source, and what's interesting to see is that the coverage is different between the different databases. There are some which covers just a few vulnerabilities, and there are some that cover everything. OSVDB might have the best coverage for the last 150 years. The quickness is also very different. Some are very quick, some are average, on average. I think it's depending on how much manpower you have behind your project. And that's the reason why we don't cover every product, because we don't have the manpower to add all vulnerabilities that got released every day. What I think is very interesting that just 2 vulnerability databases provide their own risk rating. One of them is Secunia and one of them is us. And it makes me very sad to see that CVSS scores are not very popular, still not very popular. When CVSS got released, I wasn't a big fan of it. I have written a few articles about it, which weren't very, I wasn't very supporting the project. But over the time, I realized it's unfortunately the best solution there is. It's open, it's available, and it has some level of consistency. And I fell a bit in love with temporal scores, CVSS temporal scores. Temporal scores respect every information that might change over time. For example, is an exploit available, or is a patch available? So the CVSS temporal score changes over time, and the moment somebody releases a patch, the score keeps high, and the moment somebody releases an exploit, the score keeps high. The moment somebody releases a patch, the score falls down. And it's sad to see that the other databases don't really support that, but CV is very popular, and I'm very grateful for this, because as we will see later, it makes work a lot easier. And the remaining one is feeds are very unpopular. Sometimes it feels I'm the last RSS feed user on this planet, but I still like RSS feeds, but nobody else does, so that's... Technical details range from bad to good. Some databases do not really provide information how the context of the attack might look like, with the attack vectors and how you might exploit something, and some others do. So if you just have a simple title and the description, a small description what the vulnerability might be, it's very hard to understand how to classify in your own system. So that's the reason why you have to use different sources. Then what is, I have added CertView, ExploitDB, NIST, NVD, Mitra, CVE, and they aren't really vulnerability databases in the classical sense like PacketStorm. I've excluded PacketStorm because PacketStorm has also exploits and other documents which aren't really important, or tools which aren't part of a vulnerability database. And as I said before, it's very sad that open or OSVDB isn't really that open anymore. I wish they would change their mind a bit. So there are vulnerability databases, and there, as I said before, are vendor advisories. Here are a few vendors and their pros and cons. Once again, I've made a rating, and this time it is sorted by the score. The FortiGuard and Symantec on top provides, from a view of a vulnerability database maintainer, the best information. And as you can see on bottom are Google and Apple. And what is surprising is that Microsoft and Oracle aren't that bad. Microsoft advisories became much better over the years, and they provide a lot of information. But what I have to say, some vendor advisory URLs are extremely ugly. For example, HP's, Hewlett-Packard's advisory URLs are usually 700 meters long and contain 10 different get parameters. And that feels a bit like they don't really want that you are able to share this link. They try to make it ugly so you don't share it. CVSS scores and own rating systems remain also very unpopular among vendor advisories, and I think the reason is that it's very hard to rate yourself. And I've been doing some CVSS analysis of Cisco for quite some while, and I have the feeling, I can't prove it yet, but I have the feeling that they always try to provide a CVSS score below 7.0. Perhaps they don't want the exposure that comes with a vulnerability that got a higher score. So they try to tweak the CVSS score a bit so they still keep below this threshold. Still, a good thing is that vendors also rely on CV, which is pretty cool. And some vendors do weird stuff. For example, Juniper has a field on their vendor advisory called last updated. And it's really the update, the date of the last update of the advisory, which might change over time, but they don't have a disclosure date. So if you look at the vendor advisory, the public vendor advisory of Juniper, you can't really see when this advisory got released. There are different vendors which have this problem. Xen had it a few weeks ago, and they posted it on Twitter, and they changed it, which is very nice, but others do also weird stuff. And SAP is a very good example because they are very, very restrictive when it comes to information about vulnerabilities in their products for the public availability. They only provide the vendor advisory information for their customers, and you have to provide the information that you are a customer, and then you will get a login and you are able to access the vendor advisory. But this introduces a large or a big problem for non-customers like we are. We are not a customer of SAP. So we can't really add SAP advisories in a timely manner. We have to wait until the information gets public. For example, if another vulnerability database with a customer relationship is able to collect this information, and so we can get inspired and try to add this entry. As a customer, or you might think, okay, if you are an SAP customer anyway, you have to access and you're going to look at the vendor advisories, why do you need a vulnerability database, an external vulnerability database? The problem is that many customers, as we will see, maintaining different vulnerabilities from different sources is a lot of work. And that's the reason why many customers use external vulnerability databases, because the vulnerabilities are pre-compiled and filtered and sorted and stuff like that. And they don't really want you to feed everything from the vendors. They would have dozens of different feeds, and this takes a lot of time. So if the vulnerability databases are behind schedule with the advisories, also the customers will get behind schedule, and that's not a good thing. So in my opinion, making information publicly available is a good thing for everyone. Only the bad guys get an advantage if you don't do so. Then there are vulnerability contributors, iDefense and CDI, which also provide information or vulnerabilities. This slide is not very interesting, and indeed, there are only, at the moment, 2 major players, and they are very similar. And I'd like to see more competition, or I like to see them go. I'm not really a big fan of such contributors. I think there are better ways to contribute. So, the basic idea, if you analyze or if you want to add the vulnerability to your database, is you check the different sources. There are many different sources, many lists, as I said before, and you have to review the entry that is available to you, and then you have to decide if this entry is already available in your database. You might want to merge the data, and you might want to add the references to the new source. Or if the entry is not available, you have to create a new entry. Or if the source is a false positive, you might want to deal with it. You might want to ignore the entry or flag, add the entry, but flag it so you would have to process it in the future. This sounds very easy, but it isn't really, just because there are so many different sources and there is not a very good normalization of how the information is available. For example, this is a CV entry. When I go to the website, I see the CV ID, of course, a little description. Sometimes the software name and the version number is mentioned in the description. You have an advisory URL, and you have some additional links, which is a good thing, a good starting point to add this to your vulnerability database. But there are a lot of things missing. For example, the disclosure date isn't mentioned. CV is usually not naming the correct vulnerability class, so you don't really know if it is a memory corruption, is it a buffer overflow, is it a format string, is it only denial of service, whatever. There is no risk rating, there is no mention of the researcher which is responsible for the disclosure. So you have to use another source to find this information which might be available or might not. The other example is OSVDB, and as you can see, there is much more information available. You have, for example, you know if an exploit is public, you have detailed information, which version is affected and which one is not, and you have additional links. This is a very good starting point to compile your vulnerabilities, of course. But then comes another problem. You have different sources, and what is the disclosure date of a vulnerability? The different sources have different definitions of a disclosure date. For example, on the left-hand side is the commit of a patch which fixes a vulnerability in SNMP, and on the right is the release note of the version which fixed it. And as you can see, the two dates are apart, and you don't really know which one is now the disclosure date of the vulnerability. And this little slide tries to illustrate this problem. You have the different sources. Our vulnerability database uses the 19th of February as disclosure date because it was the moment the patch got committed for the project. So in our definition, the moment vulnerability might be available to the public without restriction, that's the moment where the disclosure happens. But we are the only vulnerability database which used this date. OSVDB relied on the release notes, which were 5 days later, so they have the 26th of February. Security Focus and Secunia sometimes rip off each other, which leads to the fact that they have the same wrong disclosure date or whatever. CV uses the OSS security posting date, and Security Tracker uses the Red Hat advisory date. And that's pretty interesting. As you can see, the disclosure dates for the same vulnerability is approximately 1 month apart. So when got this vulnerability published? It's a question which is not easy to answer. So if you have different sources, you might want to put this information together, and let's try to rate the quality of the information from the different vulnerability databases. And as you can see, product and version is usually available, sometimes not always. Some sources don't use a disclosure date. NVD and CV, Mitra CVE, don't use a disclosure date. And what you might see on the first glance is that information about exploits became, over the years, pretty rare. 10, 15 years ago, when somebody published a vulnerability, an advisory on a mailing list, you were very proud the moment you were also able to provide an exploit. And perhaps the No More Box for Free movement destroyed this idea, and people became too lazy to provide exploits. There's just a vulnerability which claims, okay, I have a memory corruption, and it's good luck to guess what kind of memory corruption it is, but the vendor has confirmed the vulnerability, so there is a vulnerability, but nobody knows what it really does. A good example are VMware advisories. I've had a customer which demanded that we are going to exploit a VMware environment because Qualys reported some vulnerabilities, some high-rated vulnerabilities, and the problem was we haven't had any chance to know what kind of vulnerabilities these are. So if no information is available, you can't confirm that this vulnerability exists per definition or in your environment. And what is also very sad is that a few vulnerability databases don't link to other sources, which I think is not a good thing in different ways because it's not very motivating if you don't get the attribution. And as a customer of a source, I'm very interested in different sources because it helps me to validate and to correlate the information. So OSVDB provides the best collection and Secunia provides the worst collection. From my rating point of view, security focus and Secunia usually don't provide context. Context means you get the information that there is a vulnerability in this product and it might be this class, but you don't know if you know the authentication, you don't know if you, if it has to be full moon to exploit this vulnerability, you don't know what the context of the vulnerability is. X-Force from IBM, Security Tracker and Secunia usually, or in most cases, don't provide exploit information. So these sources are unusable. If you are a pen tester, you have just a starting point, but nothing more. So that's the reason why you have to correlate, because the different sources provide different kind of information and different quality of information. You try to merge them together and you try to compare similar data points. As I pointed out with the disclosure date, even something simple like this, like a public release date, is not easy to normalize. So you try to identify contradictions. And it often happens that, for example, X-Force and Security Focus use a different vulnerability class. And so you don't really know which class is correct, so you have to check the original advisory, and sometimes it gets a lot of effort, which requires a lot of effort to find this information that it's really the core information. And the moment you are correlating, you're running into a possible danger. The moment if you create duplicates in your database, it's very annoying because suddenly you have more vulnerabilities than there are. And what is even more dangerous is if you merge vulnerabilities. That means if there is a buffer overflow and there is a format string vulnerability, this might get patched in the same version, in the same patch, and one of the vulnerability database contributors claims this is one memory corruption. It is one memory corruption, perhaps in the same function, whatever. And you create one entry, but in fact it is two entries, two vulnerabilities with different attack vectors. And so merges or these dangerous mashups are a problem which cannot be underestimated. And then is the moment when things are getting tricky. And as I said before, I'm very grateful for CV because it helps to distinguish between the different vulnerabilities. But some vulnerabilities or some advices don't have a CV or get the CV assigned very late. So if you try to keep your database very updated, you have to deal often with the situation that there is no clear identifier of the vulnerability. And then there is another problem that many sources merge vulnerabilities into one entry. Vendors usually do that with their releases or patch days. For example, whenever an Oracle patch day comes out, there are approximately 85 vulnerabilities in their products, and they are listed in one advisory, and some sources claim this as one vulnerability entry. But of course, these are different vulnerabilities in different products with different attack vectors, with different vulnerability classes. So in my opinion, it doesn't make sense to group them together. Yeah, and the problem is if vendors or researchers aren't providing enough details about the vulnerability, you sometimes can't distinguish between them. And the best example is always the Apple Patch Day. If they release vulnerabilities, memory corruption in WebKit or Safari, you have sometimes you have no chance to understand which vulnerability is different. The only difference is that the researcher name is different, and they began to add the CVs, which is very helpful. But if these are not available, you can't distinguish. And memory corruption in WebKit, there are hundreds of them available. So which one is it, and do you already have it in your database? So one of the major tasks of vulnerability database management is not only adding the data to your database, but it is also maintaining the sources. You have to keep track of all the sources that you have reviewed. You have to keep track of all the vulnerabilities that you have processed, so you won't process them later on again, which might conclude into a collision, into a duplicate. And because this takes a lot of time to see if there is a duplicate, we have added a routine which helps us to determine if vulnerability might already been established in the database. And the easiest way is to see if the advisory identifier is already available or the advisory URL is available. And then you can check if the sources, if there are sources with the same references, and if there is a duplicate, you have to check if this is really a duplicate or if just the other sources have provided a collected entry. There is a project called vFeed, which tries to compile all the different references from different databases, from different vendors, and from different tools. And you might enter an ID of, or a CV of a vulnerability, and you get all the IDs of the other sources, which is very helpful in this case. So, as I have said, some vendors or vulnerability database maintainers compile their vulnerabilities in one entry, and when you start a vulnerability database, you always have to think. Hello? Where is er? Hello? Okay. Sorry. So you have to think about if you want to split vulnerabilities or if you don't want to split them. And this is a very good example. You have one advisory, which might include two different vulnerability classes, a cross-site scripting and an SQL injection. And the cross-site scripting is also divided because there are two cross-site scriptings, or there are two different components affected in 3 different files, and in the end there are 4 different arguments which might be used for an exploitation. So the question is, when do you split and how much do you split? Do you create 1 entry for the advisory patch? Do you create 2 entries for the vulnerability class? Or are you going to provide 5 entries for the 5 different parameters? And this discussion is really hard to come to an end, because ideally you provide 5 entries for the 5 different parameters, because the attack vectors or the exploitation is different, so it requires a different entry. But you have, in this case, you would have to add an infinite amount of entries. So the different sources handle these things differently. Microsoft, for example, provides the patch day advisory, whatever. Secunia is often very lazy and compiles them in 1 entry, but they were not lazy enough to do it for all the Heartbleed, for all the products that got affected by Heartbleed. CV is usually split, not always, but in 99% is split. Security focus is in this case split, but they sometimes compile vulnerabilities, which is pretty strange. For example, the Google Chrome vulnerabilities are often compiled in one entry, which doesn't make sense because otherwise they could also compile Safari vulnerabilities and everything else. And we try to split whenever possible, but I have to admit the moment if the same product, if two different products from the same vendor, but with the same version and from the same family, we create one entry, but we state that there are different products affected, but we usually don't copy the exact same entry because that's a waste of time. So this is a very good example. As you can see, the listing from the vulnerabilities below is how we added this advisory to our database. And as you can see, this is one advisory which contains a few entries. And so if you are Secunia and create one entry, you have much less work than we had with this entry. So when to split or not to split, it depends what your goals are. I think that splitting is a good thing because you can always group afterwards, but it takes a lot of time. So I think it depends how much man work and how much time and effort you would like to put in your database. So you have the different sources, you try to compile all the information, and it's getting hard to understand vulnerabilities, especially if there are only information fragments available. And we always check for plausibility. Sometimes there are pretty weird entries on security focus, which doesn't make sense. Perhaps they clicked on the wrong entry while they try to update another entry. We try to verify different sources, that's clear. And if the vulnerability is very interesting, then we are trying to retest it in a lab environment. And of course, we do this. This is usually part of another project. For example, if a customer really got affected of this vulnerability, we would put this additional effort in it and gain advantage in the project and gain advantage for the vulnerability database. When we started the database, we made much more lab testing, but it became nearly impossible because there are so many products and so many platforms. You can't have the lab for everything and exploit everything. And then you have to eliminate the wrong statements. Some vulnerability databases delete old entries. Some of them preserve false entries. CV and security focus do this. And what we do is we flag the entries. So we have a field which is called advisory disputed. It's a boolean field. Yes, number one means that the advisory is disputed and that it's not clear if this vulnerability really exists. And CVSS version 2 temporal scores provide the metric report confidence, and we flag them also in this. And sometimes we add additional text to explain why we might think this is a false positive. Yeah. As I said before, there are different views when it comes to disclosure dates, and there are different views when it comes to versioning. As you can see, X-Force, OS, VDB, Security Focus, Secunia, and we try to use exact version numbering. So if version 7, 8, 9, and 10 of Internet Explorer got affected, we write affected is 7, 8, 9, and 10. But this takes a lot of time, especially if the products are a bit unpopular, and if there are minor version increasements which aren't really linear, because you would have to find out, okay, which version preceded the affected version, and this takes a lot of time. So other databases, and we do it sometime in earlier entries, use wildcards, and but most of them use ranges. And what is very confusing is if a source uses the term Internet Explorer before 10, it usually means that version 10 isn't affected, only until 9 is affected. But if the same source uses the term up to 10, it includes the number 10. And it's interesting to see that, for example, Security Tracker has sometimes a bit of this confusion. And yeah, you have to look it in a much more detail to understand what the maintainers were thinking. So what about the unknown? At the moment, very much vulnerabilities are published with not much information of the affected version. If you are lucky and it is a non-vendor disclosure, they include the version they have tested it on. Usually the exploits published on ExploitDB contain at least the version that got affected. But it is often the case that earlier versions were also affected, and then you have to find out if this is the case. And it's different if you write in your database, okay, version 10 got affected, or if you write in your database version until or including 10 are affected. So you have to do further validation, you have to do more research, and we do this for the interesting vulnerabilities to gain a better level of quality. So if you have your vulnerability database, you might want to push this information. Most vulnerability databases are available on a website. Some of them provide mail subscription, old school style. Just a few provide RSS feeds or similar feeds. And we, for example, push information onto Twitter, which is not our most popular channel, but I think it might be useful for one or other person. So statistical analysis is the conclusion of vulnerability management. You might be able to do a statistical analysis, and there are different people which think statistical analysis is useless or it isn't even possible. I don't share this opinion 100%. I think doing a good statistical analysis takes a lot of effort and understanding, and it's really hard, but it's possible to get something out of your data. What is wrong and remains wrong is counting vulnerabilities, because a popular product will always have more advisories or more vulnerabilities than a less popular product. If you have a big bug bounty program which provides a lot of money, you will gain more researchers which will find perhaps more vulnerabilities. So you can't really compare apples with oranges. But we do provide statistical data on the website, and it's free for the viewer to understand or to work with them. We don't really push this statistical data. I'm a big fan of timelines because they provide for me some kind of security, because everything is defined and everything is nice. And we have different data points in our vulnerability database regarding dates. So we have just a few weeks with the Heartbleed vulnerability, which got released or which got introduced on the 1st of January 2012. I realized it would be very nice to add a field which contains the introduction date of a vulnerability. So I have the introduction date and I have the countermeasure date, and so I can see the time span, how long was this vulnerability existing, and what is the theoretical time frame for a zero-day exploit for this vulnerability. And yeah, the problem is we haven't added this data from the beginning, so we have to add it in our backlog. But I think this is going to be very interesting because you can see how different vendors react and how much effort they put in releasing countermeasures. Here are some trivias. For example, the Heartbleed vulnerability got introduced between introduction and fix 827 days. libvirt denial of service more than 1,500 days, and the Linux kernel vulnerability nearly 2,000 days until the vulnerability was found and fixed. Yeah. So I like working with data, and I think it's a good service to provide your data as far as possible. So I like to see XML exports of vulnerability databases or advisories. and we provide some CSV exports. Yeah, and I like to see people work with them and use them in their papers or whatever, because the whole industry benefits from such analyses. We are also supporting CPE, which is a format for standardizing product naming, which allows to interconnect with tools. For example, I've written an NSE script which does some vulnerability scanning based on the version detection of services, and we are going to add the CPE support to increase reliability and stuff like that. So I hope I was able to show you a bit how vulnerability management works and what the pitfalls of this work are. I'd like to thank Stefan and Steven, which supported me with countless numbers of discussions, and I think there are very much philosophical content in this topic, and I think it's very important for our industry to understand how things work in the background. So if there are any questions.
Please raise your hand. Thank you.
Thank you. I have two questions, actually. The first one is, you say it takes you time to compile all of this. And can you give us an idea of how much, let's say, man-hours or man-days it takes you to publish 15 vulnerabilities a week?
So how much time we have to use for one entry, for example?
Yeah.
Yeah, it depends. I'm very fast. I have added the first 4 years. I was the only one maintaining this vulnerability database. So I became very quickly when I see an advisor, I see immediately which information is relevant for me. And if just a few information is available, sometimes we have 2 minutes to add one entry, but only if there's just a few information. And for some entries, I've invested more than 3-4 hours, but which might also include screening through code to understand the vulnerability and to add more information. So it really depends what you want to gain from it.
And the second question is, what I'd like to see in a vulnerability database is not only vulnerability classes based on exploitation, but also based on something like CWE, as in what missing security control caused the vulnerability in the first place.
Yeah, that's very interesting. Yeah, of course. There is a lot of improvement, and I hope this industry is going to improve much more, because vulnerability databases haven't really evolved in the last 10-15 years. And yeah, if you have good ideas, I'm very happy to implement it.
Any more questions? So I guess then thank you very much, Marc, for your talk and sharing your insights.